This lesson is about the power in an inductor. First, we're going to look at a circuit. We use a very simple circuit to learn these powers. And then we talk about an instantaneous power using a lowercase p, and then the true power, P true, reactive power, PR, and then we have one example. I will show you how to find these powers using this example. Figure 1 shows this inductor circuit. As you can see, there's one AC source, Vs, and then with frequency F. This source energizes the inductor L, which is here, and this inductor has a winding resistance Rw. If you remember, the winding resistance is the resistance of the inductor due to the resistance of that material. Now let's look at these powers. The first type of power is called instantaneous power, lowercase p. So what is an instantaneous power? Instantaneous power is the power dissipated in the inductor at any moment. Since we know power, electric power, it is defined as V times I. The instantaneous power, lowercase p, is the instantaneous voltage, V of t, times the instantaneous current, I of t. The instantaneous voltage is the voltage at any moment across this inductor. And the instantaneous current is the current at any moment that passes through this inductor. The product of these two quantities is the instantaneous power. Next is the true power, P true. So what is the true power? Because inductor has winding resistance, it is the resistance due to the material that made of this inductor. The power dissipated on this resistance is called the true power. The next one is the reactive power, PR. Reactive power is the power dissipated on this inductor due to its inductive reactance. The symbol for reactive power is PR. It is the product of the root mean square voltage and the root mean square current. The reactive power also equal to the root mean square voltage square divided by the inductive reactance. That also equals to the root mean square current square times the inductive reactance. Remember, the unit for the reactive power is var. Now let's solve this problem. A 10-volt root mean square signal with a frequency of 10 kHz energizes this 5 mH coil. The winding resistance Rw equals to 5 ohm. First we need to find the true power, P true, and then we need to find the reactive power, PR. For either power, we need to find the current. The current is the key to find these powers. To find the current, we need to know the reactance. Therefore, let's find the reactance XL first. Given L equals to 5 mH and the frequency equals to 2 kHz. XL equals to 2 pi f L equals to 2 pi times 2 kHz times 5 mH. That is 2 pi times 2 times 10 to the power 3 Hz times 5 times 10 to the power negative 3 Henry equals to 62.83 omega. Next, we can find the current. The current, the root mean square current, is the root mean square voltage we know the source voltage 10 volt is root mean square is given divided by the inductive reactance XL. So this is 10 volt divided by 62.83 omega. Use calculator. I got 79.58 milliampere. This is the root mean square current that passed through this inductor. Now we are ready to find the true power. So A, the true power, power 2. So power 2 equals to the root mean square current IRMS square times RW, the winding resistance. The current, root mean square current, is 79.58 that we calculated from previous step, square times the winding resistance is 5 ohm, so here is 5 ohm. That is 79.58 times 10 to the power negative 3 ampere square times 5 ohm. Use calculator. I got 31.7 milliwatt. Unit is watt, since it is true power. Next, we need to find the reactive power. So B, reactive power, PR, that is, PR equals to the root mean square current square times the inductive reactance XL. That is 79.58 milliampere square times 62.83 omega. Use calculator. I got 397.9 milliwatt.